and good day, pre-algebra. We are tackling CO40 today, which is using equivalent rates to give us information to answer a question about a given ratio. Very, very similar to what you did in CO37, and those ratio worksheets that we worked on also really kind of falls in line with that. So there's really no explanation here other than just more practice, right? I felt like more practice with the equivalent rates, including both unit rate and ratios, would be helpful for us. So if you can run 14 laps in 5 minutes, how many laps can you run in 15 minutes? Let's set this up as a rate. What is the original rate? How is it written? You can run 14 laps in 5 minutes. A rate being written as a fraction, which is different than ratio, right? Ratio can be written with the colon or the word to, but a rate being a fraction here. What's our numerator and what's our denominator? Maggie? 14 over 5. It would not be incorrect to actually flip that around either. That's kind of the nice thing about rates, but this one flows better if you put it in laps per minutes versus minutes per laps. Kind of depends on what you're trying to ask. Question? Okay. So 14 laps in 5 minutes. That's our rate, but remember, rate is also a fraction. So our question here, how many laps can you run in 15 minutes? What do you think? How can we answer that question using the rate that we have here, Aiden?
Multiply 14 by 3, because 5 times 3 is 15.
Sure. If we set this up, 14 laps in 5 minutes equals how many laps in 15 minutes? We can see Aiden went right to scale factor, and he's saying, oh, 5 minutes times 3 brings me to 15. And if these are equivalent rates, then that means 14 times 3 is going to bring me to my number of laps, right? It makes sense. If you can do 14 laps in 5 minutes and you do that 3 times as long, you're going to complete 3 times the number of laps as long as you keep the rate constant. So 14 times 3 is 42, and that would be our answer. Okay. Next one, it takes 6 eggs to make 2 omelets. How many omelets can be made with 48 eggs? Let's set up the ratio first. 6 eggs to make 2 omelets. What's our numerator? What's our denominator? I think I said ratio. I meant rate. What is the numerator and the denominator of our rate here? Yeah. Oh, well, how'd you get there?
I took 6 for 2 omelets. 3 for omelet.
Okay.
And then I did 8 and 6 is 48. So I times the 2 omelets by 8.
Okay, so you actually kind of use 2 different methods here. Noah started by saying that, okay, I know that 6 eggs for 2 omelets is equal to 3 eggs per omelet, right? Kind of going back to unit rate there, okay? And if you went this route, if it's 3 eggs per omelet and you've got 48 eggs, how many omelets can you make with that? What's the scale factor between 3 and 48? John? 16. Okay? And so 1 times 16 is obviously going to be 16 omelets. Right? Then you kind of said you multiplied by 8. And you multiply by 8 if you kept the original rate as 6 eggs. 6 eggs for 2 omelets. And then you've got 48 eggs. Right? Here's where the scale factor between 6 and 48 is 8. So you kind of describe both methods that I was going to mention here. Okay, but it's at equivalent fractions, equivalent rates. 2 times 8 gives us the same 16 omelets that we had as an answer in the first one. Okay, so that's kind of how you're going to be approaching these. You're going to be setting them up as rates. You could go to unit rate. You could use equivalent fractions. If you already know cross products, you could use cross products. We're going to talk about that starting tomorrow or Wednesday. But your homework is to finish CO40. Once you finish that, you've got con due on Thursday. You've got a math packet due tomorrow. And of course, you got practice work that you could work on as well. Okay? That's my line. That's my math.
Don't forget to like.